As math and science teachers, we strive to provide experiences which focus on the content standards, connect the content to real-world experiences, integrate engineering design, give students voice and control, engage students with hands-on experiences, connect to a societal need. CBL integrates all of these characteristics as students begin with the big idea, develop an essential question, identify a design challenge, brainstorm guiding questions, participate in concept foundation activities, and utilize the engineering design process to create and test design products. Now, let's look at these pieces and how they fit together.
This cello is made from an oil can and wood that was thrown away in the garbage. It sounds like this.
What is sound? The essential question: how was the musical scale created? We generated interest by looking at a wave generator, and then mathematically we tied the unit circle into the sine wave and the cosine wave. First began by studying various types of musical instruments and how they generate sound. Students then broke into groups and studied various musical instruments and how they produce sound. Then we set about constructing our instruments, keeping in mind that we had to produce an 8-note scale. Here a group of students is demonstrating their pan flute by playing Mary Had a Little Lamb. And here's a picture of their final product.
This unit covers transformations, which is a math expectation for 8th graders. Using geocaching as a hook, the challenge requires students to make a coordinate grid using reflections, rotations, and dilations of a polygon to map locations. The hook involved students using their own cell phone devices. They navigated around the school using a GPS on their smartphones to various places on campus where I hid virtual treasure. This was their introduction to geocaching, and you could feel the excitement and the longing to know more. The challenge itself involved the Secret Service finding the president by decoding a map using transformations. The students used their coordinate grids, which were prepared by other teams, and geocaching to succeed. The big idea, which was tracking, locating, and investigating locations.
It's time to come up with a project, and you guys are going to help me do that. But before we can just say, hey, this is what we want our project to be, we need to have some conversations, okay? So we're going to do a lot of discussing today, and by the end of the day, you guys are going to have given me a lot of ideas so that this weekend I can go home and I can use all of your ideas, put them together, and come up with one big challenge, which is going to be a project for you guys to complete next week. So we've been talking about a GPS, which is a global positioning system, and we've been talking about latitude and longitude. So it's kind of important because we can definitely use this in everything that we do in life from day to day. You don't even know that it's happening and you're using it a lot. But to be more specific, we use it when we track vehicles, right? We use it when we need directions. Here's what happened to my phone. My phone was like, doo-doo-doo-doo. It's the phone's ringing. It's calling the satellites up here, and it's saying, hey, satellites, can you tell me where I'm at right now? So the satellites talk to each other, and they say, yeah, you know, I think that she's here, and then they talk to this one, and they talk to this one, and they said, boom, 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 back down to Mrs. Janu's cell phone. You are at Goshen Middle School. It's basically sending signals to each other, and it's calculating the distance from one satellite to the other satellite. And distance can be measured in time. So the 3 satellites talk, and however long it takes for that next satellite to get the message, they say, This must be your distance. This is where you are located on this earth. How could our big idea, which is tracking, locating, and investigating locations, how can that impact society? If you have any trouble getting started, here's an example. I know that a challenge with today's society, if we're talking about the country, a problem that I see sometimes are missing children. Right? We're always looking for missing children. It's terrible. But with technology that we have today, it's very easy to try to at least set up a way to locate these children. A lot of the times we do. Sometimes we don't. It's unfortunate. Tell me.
House arresting.
Yeah.
Chase King.
That's definitely. What, he has house arrest?
You didn't know that?
No. Right now?
Yeah.
Wow.
This is technically the only person allowed to be out.
No, I haven't.
Yeah, some kid was messing with
So
this.
house arrest is a way to, like, you know, make sure that people that aren't supposed to be out and about are actually where they're supposed to be. What are you guys thinking over here? What's a good one you've come up with?
Oh, lost phones.
Yeah. Let's talk though. I want you guys to choose one out of all of yours that we're going to talk about in class here for just a second.
How do I track down animals that are in trouble in the northern part?
Her idea, if you didn't hear her, was to track different animals. Perhaps you were saying specifically polar bears, right? And you were talking about global warming and kind of just to see, are there a lack of polar bears out there because of the warming conditions? Anybody think of that? I know a couple of you said to locate animals. How many people thought of that in their groups? A couple different groups? Good. I think that's a fantastic idea. It's definitely impacting society. Absolutely. This is the brainstorming process. First, we're going to help each other, you know, brainstorm some possible ideas, okay? And then I'm going to go home. I'm going to plan out what it is. I'm going to use some of your ideas here. For example, will GPS help us find our cars? Will GPS help us find iPhones? So I'm going to calculate everything, and I'm going to come up with a challenge. And this is called challenge-based learning. So that means that you guys as a class came up with a challenge. I didn't as your teacher. Okay, I'm just putting it together for you. So I hope it's something good, and then I'll let you know. And actually, though, I'm going to also ask the other classes too. So out of all the classes, we'll kind of figure out what it is that we want to do. I also really felt like I nailed the CBL this time, the challenge-based learning intro, to get them involved with, you know, how this affects our society, finding different locations. I think by having how that affects the society, having that discussion really got them into the unit, and then having them come up with what the project could be. They just really, I think that this lesson wouldn't have been as successful without it. So I felt like they took a lot of ownership of coming up with the lesson itself.
Teachers also receive support from a resource team of educators and engineers who assist them as they develop and implement their units.
The SEAMS project is involved with the engineering design process as well as challenge-based learning. So one of my roles as part of the resource team of the SEAMS project is to help the teachers become comfortable, help them understand, and help them implement challenge-based learning.
The teachers and engineers on the resource team bring so many different skills and experiences to the team. Here's your idea, let me help you build in formative assessment. How are you going to find out what the students already know, what their misconceptions are, and how you can speak to those misconceptions and as you're implementing your unit.
That was the roller coaster project, and briefly the concepts that I wanted them to get was how force is applied to an object when it is in motion and when it's not in motion. So looking at force diagrams were the major part of that particular one. So they built roller coasters in order to show how force keeps an object on the track at different points, so different directions and different speeds. They did really good with that one. They were really into it. I didn't have not one student say that they didn't build. Everybody built something. And there were a wide variety of different things that they built. So I was very proud of them. And the fact that they were able to really look at force and how that force differed when they would manipulate different parts of the roller coaster. And they really were able to get the idea that going down the hill forces are different than coming up the hill, forces are different than going around the circle or corkscrewing or at the end of the roller coaster versus the beginning. So we got a chance to look at some key concepts like potential energy, kinetic energy, gravitational potential energy. They were able to look at force diagrams and actually make and illustrate some.
2, 1, go!
Okay, basically to find the equation for the ball, we dropped the ball in front of some meter sticks and we recorded it to figure out how far the ball fell every time, like in what time. So that helped us find the acceleration of the ball, and we used the information that we found, where like the distance that the ball had moved at the time, to make like a graph, and then we plugged that into a graphing calculator and found the equation. And the equation for our ball was y equals negative 426.5x squared plus 57.8x plus 420.37.
In order to find the equation for the car, we took 5 meter sticks and lined them up down the hallway and marked off for every 10 centimeters. Then we filmed that and then we put it in the movie maker to look through frame by frame and where the car was at each kind of move. Took that and put it in the graphing calculator in order to find out what the equation would actually be.
So our stunt wasn't successful, and well, we made our car 1,369 centimeters away from the ball drop region, and our car failed pretty badly.
If we do this again, we would get more precise measurements. We would also like to make the distance between the car and ball drop region shorter.
Okay, so how would you get more precise measurements?
In order to get the more precise measurements, we had a better quality camera to film it, so we were able to pinpoint where the car and the ball location were at that exact moment.
Correct. Same thing with your car. The car's equation is altered based off of where it started. So make sure that you take that and keep that in mind. It does affect it. However, I appreciate the way that you address the fact of your communication. In engineering, it's the same thing. You may not have all of your coworkers there at the same time, so communication becomes crucial. There actually could be one person from America, one person from England, and one person from Australia, all working on the same project. And if you don't leave good detailed notes of exactly where you are and exactly where you came from, that next person that's going to pick up on that project will have to start all over again. You ready? I know in my job in the Air Force, it worked on a shift. I had to document things 3 times if I did something. If I went out there and I screwed a panel onto the jet, I would write it in the forms on the jet. Then I would go in and type it into the computer. Then I would go into my office forms and I would write on my office forms. They were tracked 3 different places because noticing that communication is key. If one person does something and no one else knows that they did it, one, it's either going to be done again or it's going to be totally forgotten about and can end up screwing everything up. And F-16s are worth millions of dollars. So something like that that's forgotten, a jet goes down, the first thing they do is go to the forums to see what everything was done. If you're going to go into engineering, you need to make sure you're focused on that. If you're not going to go into engineering, you want to open up your own business, you need to focus on that. So if yours was close to this, then your ball equation was pretty close. I would love to give you the equation of your cars and what they should have been, but none of your cars fire the same. That has to do with how you made your car. Some of you set it up to where your car had a little bit of wobble. Well, that would affect it. The way that your screws were placed on your car and how far they were from front to back kept it more on a straight line. If you screwed it very close to the car, that string was rubbing up against the car and causing friction. None of your cars were the same equation. So you can see none of the equations of the cars are the same. And I've talked to numerous people before this whole project started. 2 physics professors at UC, an engineer with a PhD, a science teacher that has gone through and now writes tests for future science people. All right? None of them gave me the same answer as to what to expect for this equation. One physics teacher said, the college physics level, they said that you could probably expect it to be somewhat logarithmic because a rocket could be logarithmic. Well, I was like, shoot, that's going to screw me up pretty bad. That's an equation you haven't studied yet. Then another one said, I think they could approximate linear on a short distance. And another one said, well, it could approximate quadratic on a short distance. Nobody knew 100%. So the thing that was happiest for me when I saw you do this was your R-squared values. Because what did you notice when you saw your R-squared values? A lot of you were getting what? What did your group get? For your car? 0.995 for it being a what? Quadratic. That means it approximated, really close to a quadratic at that point in time. At 0.99 probably explains why your group was successful.
People that I've met are such wonderful educators. We really bounce ideas off one another. I've learned so much. It's fun. You go in and you are students again. So you get to create, you get to engineer, and giving them this hands-on experience, really making them work on their own without me telling them what to do, really builds their confidence, and I think helps them see their future in a new light.